SQL Saturday Lisbon either, and I was killing myself, and I should have at least learned hello. I didn't even learn hello. Awful. I should move Twitter up so I can take questions. Oh, Matan's got a picture of me over there. Oh, there I am. Oh, I see myself now. That's funny. Oh, you can make me. I didn't even think about it. Well, we'll leave this up until we're ready to get started. But for some reason, I feel like I'm missing something. Like I should have a laser pointer in my hand, or I don't know what's going on.
I think we can start. It's already 5:30, so I will pass you the keyboard and not keyboard. Change presenter. Here it is.
All right, show my screen. See you. Hopefully, it's showing my screen with. Let's see if it shows. Yeah. Okay. Good. Perfect. Let me put this in presenter mode. All right, so now can you guys see the slide deck?
Yeah, it's fine.
Oh man, it's starting already. Let me make sure it doesn't start it all of a sudden changing slides. And I'm like, no. You do this right. All right, so hi ladies and gentlemen. Today we're going to be talking about troubleshooting shared storage and solid state drives for SQL Server. I'm Brent Ozar, and I care about this because I used to have all kinds of problems with my storage when I was a DBA. I was absolutely positive it was a problem with the SAN, and I thought I would change to RAID 5 or RAID 10 or buy different drives or change the way my log files were set up. And almost the whole time I was doing everything wrong. I learned this after my SAN admin quit. I walked into his office and I told my boss, I will do all of his work and you don't have to pay me any extra as long as I get all of the passwords to the SAN and I get his training budget. So that way I could see whatever I was missing inside the SAN. And what I learned was it was almost always my fault as a DBA. I wasn't doing things correctly, and now I want to help you understand what we can do better to get better performance out of our shared storage and out of our solid state drives. What we're going to talk about tonight is the parts of a SAN, especially the pathing parts of it, getting our data from the SQL Server to the SAN and backwards, how to test that storage throughput, and often why your SAN administrator says, well, there's nothing wrong with the SAN right now. It must be a SQL Server problem. By the end of this, you'll understand why that is. We'll also talk about why TempDB makes so much sense on solid state drives. And we're going to start by looking at a server. This is an HP microserver that's sitting in my office in my lab. It's a very small box. It's about the size of a stack of books. And if you open up the front of it, there's 4 hard drives inside. Let's say that this is my SQL Server, and I want to take out the data and the log files, and I want to put them somewhere else. I want to put them on the SAN. What does that physically mean if I take those drives out? Well, the first thing I'm going to do is remove the hard drives and set them in a stack. So I'm going to have them all stacked up. Those data files are going to live somewhere else. But I also need something called a RAID card or a RAID controller. This is a little bitty computer that sits inside your server, and it's got a chip on there that says where each piece of data lives. Because if you've got 4 or 10 hard drives, we need to figure out which parts of which data files live on which drives. This part also has memory on board, so it will cache things rather than having to go out to the drives, just like SQL Server does. You know, in SQL Server, you have the buffer pool where you cache data. The SAN has it, or this RAID controller has its own memory as well. It also detects when hard drives fail, rebuilds them from scratch. So now I've got my data files and my RAID controller living somewhere else. I also need to connect them with cables because this network part of it is going to become very important. This is how storage becomes separated from our servers. We still have a server with host bus adapters in it HBA. It's just a fancy name for a network card. Sometimes it's fiber optic cable, sometimes it's iSCSI over Ethernet, but they're really just network cards that connect us to the shared storage. That SAN, the 3 letters SAN, really refers to the network of cables and switches that connect between our servers to the shared storage gear. So there's 2 separate parts we're going to have to worry about configuring to go fast. One is the network and one is the shared storage gear itself. See, storage is really a lot like libraries. You know, when you go to the library, you check out books. You could have a giant library. In the U.S., we have the Library of Congress with millions and millions of books. But no matter how big your library is or how many terabytes of data you have in your storage, it all comes down to how quickly you can get it out through the checkout lines. See, we don't read books at the library. We check them out and work on them somewhere else. It's the same thing with your storage. Just because you have terabytes worth of data doesn't mean you can get it out quickly. And that SAN, the storage area network, is the checkout line for our library. I used to think that fiber optic meant it was incredibly fast. The fiber optic lines were the speed of light, so there couldn't possibly go any faster than the speed of light. That's not actually what it means at all. The whole goal of this storage network is to never go down, ever. SAN administrators are so paranoid that they make database administrators look like drunken gamblers. These guys never, ever take risks. And so as a result, they build these complex networks, but they're not as fast as you think. They're just really, really reliable. And they're not always that reliable, although they are more reliable usually than our SQL servers. So how are these networks connected? Well, the most common methods are there on the screen in order from slowest to fastest. 1 gig iSCSI is the same network cables that you use to connect your laptop to the wall or your desktop to the wall. It is nowhere near quick. You've copied things over a network before. You know that that's very slow. Well, that's exactly what 1 gig iSCSI is. As you step up a little and talk about 2 gig fiber channel or 4 gig fiber channel or 8 gig fiber channel, these are the speed of light, but they're really not all that quick. I need to turn this into numbers that will make sense to you, because 1 gig, 2 gig, 4 gig, what does that really mean? Well, here's a great poster that Kendra Little, one of my co-founders here at Brent Ozar Unlimited, put together. This shows you, for every one of those connection methods, how fast it will take to transfer 1 gig worth of data. See, if you've got 10 gigs worth of data on disk and you need to scan that table, how long does it take to read those 10 gigs? At the bottom of the very fastest one on there, the 10 gig iSCSI, it takes 800 milliseconds to transfer 1 gig. That sounds kind of quick. Until you think about 10 gigs worth of data, it will take 8,000 milliseconds or 8 seconds to read that data. That's the fastest your query would ever finish if it needs to read 8 or 10 gigs worth of data. It's 8 seconds. And you start thinking about 100 gigs or a terabyte worth of data. This is why queries can take minutes in order to finish if we haven't cached the data in RAM. There's no rocket science here. However long it takes to get the data across those slow cables, that's how long it's going to take our queries to finish. Even before I talk about doing things like functions or work in CPU with SQL Server. Right now I'm just talking about dragging it off the cables as fast as I can get it. This brings in the whole concept of storage pathing. How do I get data from my SQL servers to the SAN or vice versa? And in the very simplest terms, I have my little HP ProLiant there, my little microserver. It's got this host bus adapter in there. Now suddenly I care a lot about how fast that card is. how quickly it can transfer data from one place to another. It's connected in with a cable that goes into a switch, and then finally out to my shared storage gear. Except your storage doesn't look anything like this. It's at least this complicated. See, your storage administrator, again, I said it's very conservative, it's very not friendly to failure, it's very risk averse. So he or she wants to make sure this never goes down. They will build two completely separate fabrics. That's what they call switch networks. Multiple fabrics so that if even one switch goes down or you lose a patch cable anywhere in here, everything still keeps running without anyone noticing. It's a lot like pretend that you absolutely had to get to YouTube to search for your lolcats or whatever, I can has cheeseburger. At any time, you might get two separate internet connections from two separate places. Maybe one's going over Wi-Fi and one's going over to Ethernet. Now, YouTube at the other end of the line is going to be pretty reliable. It's just the network connectivity in between the two that we're really worried about. We like to think that the more connections that we add in, the faster it's going to go, but that's not necessarily the case. More on that in a minute. Now, this is even a really simple version of pathing. In real life, it's usually much more like many cables involved from the storage to the switches, and often multiple sets of switches involved on each fabric. But it doesn't mean that you're getting more performance for a single, say, data file or log file. See, multipathing, or using multiple paths at once, is a lot like active-active clustering. The name active-active is really deceiving, and we tell people not to use that term anymore. What it really means is that you have multiple instances of SQL Server that are each serving different databases at the same time. You don't get twice the throughput simply because you add twice as many SQL Server instances. Each instance is serving different databases. That's exactly what active-active multipathing means for most storage out there. Active-active multipathing means we might have different cables that are serving different purposes, like maybe one is serving my data file volumes and one is serving my log file volumes, or TempDB. What this means in another way of saying it is each path could carry data for a different drive letter, not necessarily reading across all of the paths at the same time. If you have a 10 terabyte database that's only got one data file and only all on one drive letter, you may not be able to read data across all of your paths simultaneously, or you might be able to write data across multiple paths to it, but not read across multiple paths to it. This gets really complex, and it's really based on what kind of make and model of storage that you have and whether or not you've correctly configured the multipathing drivers. This is not something that we think about as database administrators. We just think it's plugged in and multiple cables are plugged in, so it must be really fast. And that's never the case. It can get even worse if you're using multiple SAN switches. On the left-hand side of this diagram, I've got a single SQL server with 4 host bus adapters plugged into it, each of which has exactly 1 gig of network throughput going out to the SAN. All 4 of those are plugged into the same network switch. Over on the other end, my storage processor or SAN controller also has 4 network ports, all of which are plugged into a different switch. But these 2 network switches are only connected together by a single cable. Guess how much throughput I'm going to get? Not a whole heck of a lot. I'm going to get bottlenecked by this one individual cable going between these 2 switches. This is why when I work together with SAN admins now, we sit down and sketch out the whole infrastructure on whiteboards, show me all of the SAN switches, each of their speeds. They can each be different speeds. each of the port speeds, because some things could be plugged into 16 gig fiber, some into 8 gig fiber, some into 4 gig fiber. And then sketch all of that out to figure out where the slowest links are, because SAN admins rarely have the time to monitor each port in the network, just like you don't monitor network port utilization in your SQL servers. You've got better things to do, like try and figure out if the databases are even up and online at any given time. So we're going to have to test this. We're going to have to start testing how much throughput we actually get to each of our ports and even to each of our drives. We're going to start with the easy button of storage testing, Crystal Disk Mark. This is totally free, and you can install it on any server, whether it has SQL Server or not. I like installing it on my desktop even, just to check out my hard drives on my desk. Well, hard drives. I haven't had a hard drive on my desktop for like 4 years now. The solid-state drives on my desktop. There's my little MacBook Pro over there. And it's funny how often my MacBook Pro is faster than some people's SANs. So anyway, faster than most people's SANs, really. It's not because it was an expensive laptop either. Just solid-state drives are pretty freaking quick. So what you do is you go download this from brentozar.com/go/cdm. There's 3 drop-down boxes across the top that you're going to configure. The first one is the number of tests that you're doing. If you're doing this in production, when the SQL Server is up, you should only do 1 test, because I don't want to do a long, sustained test that might cause my SQL Server to slow down dramatically while it's working. The second thing that I'm going to configure is the size of my test file. I want it to be 4 gigs, or 4,000 megabytes. If you're watching a recording of this later, I want it to be the biggest file size that Crystal Disk Mark ever supports, because after all, your database is large. Your database is way larger than 4 gigs, and I want to make sure that your data file size, or your cache, the testing file, is larger than the size of your SAN's cache or your solid-state drive's cache. I don't want to just get in-memory results. Then finally, the last box, the last drop-down there, is which drive letter you're testing. You want to test your data file drives, log file drives, TempDB, and even the C drive, because often the C drive is faster than where your SQL Server data lives. That's always fun to go into the SAN administrator and say, well, we've decided to put all of the data on the C drive instead. That seems like the smarter thing to do. So after you've hit configure those 3 drop-downs, you click the All button up at the top of this top left there. This fires off all of the tests, and then you go off and go get some coffee. You're really only going to pay attention to 4 of the tests. The top line there is sequential operations, long sustained reads or sustained writes. The left-hand column is the reads, the right-hand column is the writes. And there's no rule as to which one of these is going to be faster. This often depends on whether or not your storage has a lot of cache. The more cache that it has, it's going to consider writes committed as soon as they hit the cache. Anyway, the point is, out of this top operation, this is a lot like backups, or when you do a big select across a table that's way too big to fit into RAM. You've got Enterprise Edition, so it keeps telling SQL Server, keeps telling the storage, hey, keep bringing in data as fast as you can. More on that in a minute. Now this top one is usually going to be the fastest that your storage can possibly perform. So you may see it hit a certain number very quickly and stop there on both reads and writes. The middle 2 sets we don't really care about. These have nothing to do with how SQL Server performs. The bottom one is kind of, sort of similar to how an OLTP server works, a transactional server that's jumping around a lot, doing small inserts, updates, and deletes all over the place. Think SharePoint, Dynamics, accounting software. It's also akin to TempDB, because if you've set up your SQL Server correctly, you're going to have multiple data files, so SQL Server will be jumping around in there. That bottom line of testing in Crystal Disk Mark is 4K operations done 32 at a time. Now, 4K isn't exactly how SQL Server works. SQL Server usually works in 8K chunks, but this is close enough. For a 1-button test, this is pretty darn close. So the bottom line is going to be way slower than the top line. That's okay. This is normal with storage. The more random our operations are, the slower that they go. Now, you'll quickly get numbers out of there. That whole test runs at 5 minutes typically with most storage. But if you want to go even deeper, you can use SQL.io. This is the worst named tool in history. It has nothing to do with SQL Server. It doesn't require SQL Server. It doesn't mimic SQL Server. I don't want you to try to mimic SQL Server, because as soon as you do, whenever you try and configure it so that it works the way SQL Server does, your SAN admin is just going to say, well, that sounds like it's a SQL Server problem then. I want to avoid that. I want to make this thing go as fast as it possibly can, regardless of what kind of application I'm dealing with. I've got an exact set of recommendations there at brentozar.com/go/SQLIO. And you'll see in there out of the results, it's not very pretty. It actually runs in a command window. It'll give you the number of megabytes per second that your storage will do. This is the same megabytes per second the Crystal Disk Mark is giving you. It's just that this pushes your SAN much harder. Now, you should not run this. Ooh, there comes my Gmail notification. You should not run this on a live server, because you can actually cause the SAN to fail over when you do this. There's some big name brands out there that will simply fail over and restart whenever they encounter really big SQL.io tests. And in a modern SAN or in a modern storage gear, it'll have 2 processors or more, so it'll fail over from one to the other. Your servers will only have a brief moment, maybe 1 or 2 seconds, maybe 15 seconds, where they can't access their storage. This is dangerous. I mean, most storage gear, it'll fail over seamlessly. It'll just look like writes are taking a really long time. However, you don't want to do this in production. But I will tell you that what if your SAN admin was a real jerk? And what if you knew the SAN was slow and you could take a maintenance window where you could run your tests, where you stopped SQL Server, made sure you didn't have any production databases running, and then you run this test. If the SAN did fail over and cause a brief outage, then you could play dumb and say, what do you mean? Are you telling me that just by running a program I can cause the entire SAN to fail? That doesn't seem very safe. Is this really, have we tested this? Is this safe to run production gear on? And then the SAN admin will freak out. I am not recommending you do that, but I will say that is something that I did when I was a database administrator. In either case, whether you're using Crystal Disk Mark or SQL.io, you're usually going to hit your cable's bottleneck first. For example, if you have 4 gig fiber channel, one of the middle numbers there, you're going to cap out lower than 425 megabytes per second. No matter which tests you run, you might keep running up against, say, 300 to 350 megabytes per second. Because those numbers on the right-hand side are theoretical max bandwidths. They're not even the real bandwidth, might be much lower than that for things like protocol overhead. So you'll probably cap out at around 300 to 350 megabytes per second. When you do, stop buying things. Stop buying more drives. Stop trying to switch between RAID 5 and RAID 10. Your bigger problem is this cable that's connecting your server to the SAN. Really fun stuff. Your goals here is to use Crystal Disk Mark as an easy button test in order to get a quick idea, and then finally graduate up to SQL.io to really push it hard. Reimer asks in Twitter, what about iometer? Iometer's okay. There's a lot of other tests as well. These are just the quickest, easiest ones that I like to use that do a decent enough job of really pushing your storage to the limit. Iometer's better if you want to try and mimic an application, which, frankly, as soon as you do that, the SAN admin is going to say, that's an application problem. Then, my goal with all of this is to make sure that I can achieve SQL Server's maximum consumption rate before I even install SQL Server. I need to make sure that that I/O subsystem can produce a certain amount of throughput first. So what is SQL Server's maximum consumption rate? How fast does your storage need to be in order to keep SQL Server storage busy? Now think about for a second, when you run a SQL Server select query, when you fire off a big ugly query, and you notice that your CPU only goes to like 10% while the query's running, that's not a good thing. I want my CPU to go straight up to 100% while this query is running and then fall right back down to 0. That sounds kind of crazy for a DBA to say. Why would I ever want my CPU to go up? But why would I want it to stay low? I paid a lot of money for my SQL Server licensing. I didn't pay that so the CPU could sit around bored waiting for data to come in. I paid that so SQL Server could chunk through a whole lot of data and then fall back down and go idle. So how do we drive a lot of data through our SQL Server? Well, Microsoft actually has a great document telling you how. It's called the Fast Track Data Warehouse Reference Architecture. And it's a design document that's really meant for vendors. It's meant for hardware vendors like Dell, HP, IBM, Cisco, whoever. What this does is it tells them how to build hardware for SQL Server. It says if you want to go out and sell a data warehouse, you put together this many processors and this much memory and this much storage throughput and this much network throughput, and then make sure that it achieves certain speeds, and then it's good to go. You can use this reference architecture with your own hardware. You don't have to go buy these expensive data warehouses from vendors, although the nice part is that if you do buy them from these vendors, they're guaranteed to perform. The key part to this document is balancing three things. See, SQL Server runs on CPU, which needs to get its data from your storage network, which needs to get its data from the hard drives or solid-state drives. This here is a kind of an ugly diagram illustrating those three things. They're all broken out into numbers. 2 Xeon processors that have 6 cores are able to consume their MCR, maximum consumption rate. They are able to consume 3,168 megabytes of data per second. It's a really big number. That is assuming the CPU goes straight up to 100% while it's churning through all that data. Well, in order to satisfy that, we have to have 4 8-gig fiber adapters that are all able to deliver in total able to deliver 3,123 megabytes per second. And in order to keep that busy, we're going to need 48 hard drives laid out in a bunch of RAID 5s. Now, I know, DBAs usually think that RAID 5 is worse than RAID 10. There's a reason why it actually does make sense in data warehousing. More on that in a minute. I need 48 hard drives, all dedicated just to this one SQL Server with 2 Xeon processors in order to keep them busy. Often, we underspec those big time when we're dealing with SQL Server. SQL Server handles way more than you think, way more data. The starting point, the bare minimum that we should ever consider, is 200 megabytes per second per core of data. But often, when I'm dealing with storage benchmarking, we're only able to get 200, 400, 600 megabytes per second of data out of our storage. Our storage is just nowhere near fast enough. This is one of the reasons why we really recommend people put as much memory as they can into SQL servers, because that way you do an end run around this entire storage problem. You're able to just get this data from RAM and simply take off. Now, the hardware vendors will give you sample configurations. This is a sample document from Dell's back in SQL 2008 R2. And don't worry too much about the versions of SQL Server involved with this. The versions of SQL Server haven't really changed much for I/O purposes since SQL Server 2000. Now in 2014, things like Hackathon and clustered column store indexes really rechange all of that, but the way that they work is entirely in memory, not in storage. Notice when we talk about Hackathon, for example, you need twice as much memory as you have data in order to make that work. And the details on this are astonishing. They tell you exactly what hardware you need and exactly how to plug it in. For example, at the top here, we're looking at the back of a Dell PowerEdge server, a little 2U server with 2 processors in it. And it tells you that you need 4 fiber cables coming out of this in order to keep it busy. And those 4 fiber cables have to be plugged into 4 different zones on a switch, because we're able to overrun that switch's throughput, the switch's memory and buffers, if we plugged all 4 of them into the same part of the switch. Then it also tells you exactly how to plug it into the storage gear as well. It's beautifully detailed, and you can use all of this with your own hardware, right down to exactly how you need to configure everything. You need this minimum version of firmware for the switches, this version of multipathing software, because as the vendors go through and test this stuff, they encounter bugs that they turn around and fix with all of that storage, with all this firmware and BIOS and drivers. They fix that and then establish a new minimum version that you have to have in order to run SQL Server on this gear. It's beautifully detailed. It goes into exact specifics on things like dynamic cache read prefetch, how this is different between data and log files. You don't have to understand all of this stuff, but you do have to go present it to your SAN admin and say, did we configure our storage this way? And if not, why not? Even goes into crazy details like showing you how you configure LUNs and how many virtual drives you need, how many data files you need. And it even tells you things like RAID 5 and explains why. Because see, when we do inserts, updates, and deletes in SQL Server, the data needs to get to the log files instantaneously. The log file is what's holding up our transactions. But the data file is written to asynchronously behind the scenes when we do checkpoints. RAID 5 has this reputation for being really slow at writes, and it is, but who cares? I care about data file read speed, not necessarily write speed. There's all kinds of interesting things that we have to get into here. It even tells you things like how many data files that you need, how many data files you need per core, and it goes into beautiful details all to drive the maximum amount of throughput that we can possibly get. See, here's the ending results out of that Dell document. You should be able to drive 3,168 megabytes per second all the way down to SQL Server's cores in order to max out CPU and get that to go as fast as humanly possible. Now, how do you get all of this for your vendor? The awesome part is that your vendors already provide this documentation for free. All of the big vendors, even Cisco, the new guy on the block, all provide these, and you can download them to see exactly how you should configure your SQL Server. And also, you can keep up with the latest and greatest ones just by Googling Fast Track Data Warehouse Reference Architecture. Now, your SAN admin, though, is already monitoring the SAN. And when he looks at the SAN, he has these little red, yellow, and green color-coded reports, and he goes, you know what? The SAN is just sitting around bored. It isn't a SAN problem. Well, the reason why, one of the reasons why, is those tiny cables between your server and the SAN. Your server is trying to drink a whole lot of data through a really tiny straw. And the end result is your SQL Server sucking as hard as it can on that straw. Nothing's coming through the other end. The SAN admin is monitoring the glass at the other end and going, come on, I got plenty more here. Come on, you could go much faster, drink harder. And he doesn't know how small your straw is, and that's where your real problem often lies. Most likely, only one of your paths, one of your straws is getting used, and in order to really drive as much throughput as possible, That's where you have to start getting into this multipathing concept and referring to the fast-track data warehouse reference architecture. Another reason why the SAN is sitting around board is you might be using SQL Server Standard Edition. See, Standard Edition just doesn't push storage that hard. I think Enterprise Edition is wonderful, and I wish Microsoft did a better job of explaining just how good it is. If you go into Books Online and you hit the section on Reading Pages, there's a thing in here that says SQL Server Enterprise uses more prefetching than other editions of SQL Server, allowing more pages to be read ahead. The level of prefetching is not configurable in any edition. If you start to do an index scan, you have a big long table, 10 gig, 100 gig, 1 terabyte table, and you're scanning the whole thing because you don't have the appropriate indexes on there. So you're scanning the whole thing from start to finish. Enterprise Edition says, whoa, you see what he's trying to do? He's trying to read the whole table. Let's go get storage. I'm going to tell Windows, get this entire table and just keep bringing the data in as fast as you can get it. Trust me, I'm going to scan through all of it. Even though I haven't asked for it yet, you just keep bringing it in. Bring it in at 512K at a time, which 512K is a really large amount to ask for storage. It doesn't sound like much, half of a megabyte, but it's really a lot when we're talking about dealing with storage. Standard Edition, on the other hand, works in individual 8K to 64K increments, like 10 times or 100 times smaller. Just says, okay, I need a page. All right, I'm done with that page. Can you give me the next page? He sits around waiting. Oh, you got the next page. Okay, I'll take it. All right, I'm done with that page. Can you give me another page, please? Storage sucks at doing very tiny reads. It's great at doing very long sequential reads. That's where Enterprise Edition really starts to take off and shine. It also has really cool things like a merry-go-round scan that'll make even more efficient use of your storage. It's a feature that I wish even more people knew about Enterprise Edition, and it really does make a difference. This is why it's pretty much a standard requirement that when I'm dealing with customers at a terabyte or more of data, you have to be on Enterprise Edition. It's really the only way you're ever going to get the performance that you want. Another reason why the SAN might be sitting around board is that your SAN admin is likely taking average measurements, looking at the SAN's read performance once every minute or combining every minute's worth of activity into a single number. Your queries often come in large groups, especially if you have things like scheduled reports or all your users sit down at one time. When your SAN admin looks at the SAN, he says, well, on average, we're doing pretty good. And even my peaks aren't too bad. SQL Server, on the other hand, tracks every single read that we do from storage in DMIO virtual file stats. It's a DMV that we can query to see how fast storage is responding. This is why SQL Server's reads may look very different from the SAN control panel's reads, because we're just doing them in completely different increments. The other thing we have to look out for is your SAN admin has to configure the storage processor correctly and may not have done so and usually has not even done so. Configuring the storage processor or the RAID controller, depending on how we want to name it, has three real parts to this. I want to get the fastest processors with the most cache possible. I want to configure them to do as little work as possible and then buy the fastest cable and drives that I can possibly get. And it's funny when I think about getting the fastest processors equipped with the least memory, or with the most memory possible, what does that really mean? Well, storage gear has CPUs just like your SQL Server. This is a screenshot out of EMC's documentation for one of their VNX processors. Notice that it has just plain old Xeon dual-core and quad-core processors. Yes, dual-core and quad-core. I bet you're not even installing SQL Server on dual-core processors anymore, and yet you're dealing with storage that may have just plain old dual-core processors with hardly any memory in it. And look at that total read and write cache per system. This is how much memory each of your SQL servers gets in terms of cache. I know a lot of SAN administrators who say things like, hey, don't worry, the SAN caches things, or hey, don't worry, it's considered committed as soon as it hits the cache. But if you look at how tiny that cache is, take the read cache on this particular SAN. Each server only gets 64 megabytes, not gigabytes, megabytes of cache. I bet your SQL server has at least 16 gigs of memory. What are the odds that your SQL server is going to need something out of cache, out of your own 16 gigs worth of cache, and you think that's anything you need is going to be in this tiny little 64 megs of cache? Not even close. All this is really good for is doing things like prefetching, reading ahead large quantities of data that are only going to work hand in hand with Enterprise Edition. When Enterprise Edition says go off and keep fetching in data, these caching numbers are laughably low compared to how much SQL Server has in terms of cache. And even this processor may be really low in terms of cache because that processor has to do all kinds of things. Alerting, monitoring, deduplication, security, backups, all kinds of stuff, including things you may never have thought of. This is a screenshot out of a storage vendor EMC's manuals. EMC actually lets the SAN do antivirus inside the SAN. I know a lot of DBAs say, I would never run antivirus on a SQL server. That's crazy. It uses too much power. You might even be doing it inside the SAN and not even know. In order to really configure this stuff correctly, you've got to follow the best practices from every single vendor. Get the fastest processors you can. Have those processors do as little work as possible. Don't enable any extra features you're not actually going to use. And get this stuff all configured as quickly as possible. Thankfully, the vendors have great detailed documentation that you can use with your SAN admin to get them configured as quickly as possible. Now I'm going to use an example from IBM, but all of the storage vendors do this. I'm going to show you where to get them here in a minute. This is IBM's mid-range system storage implementation and best practices guide. Your first clue that this is good is this is an 11 meg PDF with no pictures. It's really hard to make an 11 meg PDF with no pictures. Trust me, I've tried. Now, if I read the description of this, it says things like, we look at performance implications for various application products such as DB2, Oracle, Tivoli Storage Manager, Microsoft SQL Server. Now, I am going to forgive them for not capitalizing SQL Server correctly, only because the rest of this document is so very good. As we go further down through this document, we're down in 7.3, page 126 for Windows as well. This is a big flipping document. We cover the following topics, and there's a bunch of things in here that are for not just the DBA, but also for the SAN admin as well, telling you exactly how to configure everything. And it goes into beautiful detail for this particular make and model, not all makes and models, but it says RAID 1 or RAID 10 must be used for the databases, TempDB, and transaction logs. It didn't say this is a good practice. It didn't say for best performance. It said must be used. This isn't the truth for all SANs. It's the truth for this SAN. As we go deeper, talk about user database files in this particular section. It says use the 15K disks rather than the 10K disks. Avoid using SATA for the databases. It doesn't say it's okay if you mix things in a big pool. It says you can't use SATA drives for the databases. Often we don't read this kind of documentation. We buy whatever's right for our budget, not what's right for SQL Server, and that's why things end up slow. Then even when we buy the right stuff, we have to go exactly by what the caching settings are and what read-ahead multiplier enabled is and things like that. I don't have to understand what these features mean. I just have to go into my SAN administrator's cubicle and say, here, This is what the vendor shows for us to do with SQL Server. Have we done this? Can you show it to me in the control panel where we configured this for SQL Server? Goes beautifully into transaction logs as well. Transaction logging is sequential write I/O favoring RAID 1 or RAID 10. Note that RAID 5 is not suited for this use. Really beautiful detailed documentation here. Now you can get this documentation for your own SAN at brentozar.com/go/SAN, where there's detailed documentation for Dell, EMC, IBM, Hitachi, all the big players out there in terms of storage. Now if you can't find it on my site, what you can also do is Google or Bing. I support alternative lifestyles as well. You can Google for whatever your make and model of SAN is, and then SQL Server, best practices, site : and then whatever your brand name is, like EMC.com or Dell.com. This restricts the results just to that one vendor site, so you know you're getting the official documentation. Don't worry about whether it's for SQL 2000, 2005, 2012, 2014. I/O really hasn't changed in the last 5 or 6 versions of SQL Server. We still approach I/O the same way. Again, hackathon and clustered column store indexes are different. That's where you have to have multiples of your memory there, not storage as much. And these documents are extremely expensive to produce. They're hundreds of pages long, so the vendors don't usually update them for every single version of SQL Server that comes out. There's going to be parts in there that you have to do as a database administrator and parts that the SAN administrator has to do. And it really is important. It'll tell you things like the number of files per file group, whether or not you should put data in the primary file group, whether or not you should put data and logs on the same drives. This is actually different per make and model of SAN. This is why you don't get good advice just out there as a general rule. It's not like one person can say data and logs should always be on separate drives. And I laugh at these bozos who say that they should always be, because that's not the case. You'll find out when you read your SAN vendor's guidelines. You don't have to do everything exactly the way that they say. But whenever you do something different, you have to be able to explain why you did it. Because if you're just guessing, you are going to be wrong. For example, some people like to put their log files on dedicated drives. That can be cool as long as you have all 4 of the things that I list there on the screen. Most people don't. Most people don't even have one of these things, let alone multiples. If not, you're usually much better off, depending on your SAN vendor's guidelines, doing one big pool of drives, putting everything on the same drives, because it's easier to tune those and get it right than it is to tune little individual groups of drives. You will get that wrong. So man, for the last 45 minutes, I've been talking all about how tough shared storage is and even how tough local storage is. And this is where solid state suddenly becomes amazing. See, if you pop open a solid state drive, it's really a lot like a SAN. There is a cable interface, something like iSCSI or Fiber Channel, except it's different. This is going to be SAS or SATA that plugs directly into your server. There's going to be a RAID controller built into the drive. These things have their own little drives, quote unquote, which are NAND chips. Memory chips are just like hard drives. Each individual chip can have parts of it that fail. And so the controller will parcel out where all of this, where this data lives, which parts of your table live on which drives, and helps correct some of the errors. Each of these parts needs to be as quick as possible. And that's why when we look at different drives, even though they're made completely differently, they all end up being the same under the hood. This is a thumb-sized drive that comes out of an Apple MacBook Pro or MacBook Air. It's got a little interface that plugs into the Mac. It's got a controller that's like a RAID controller, and then a bunch of NAND chips. Or a PCI Express drive like Fusion IO or Intel or OCZ. This has a cable interface, meaning PCI Express, which is blazing fast. This is one of the reasons, but not the only reason, why these types of drives are usually faster, and often even faster than your SAN. They have their own blazing fast controller, and then look at how many NAND chips we're talking about. Here we're talking about 12 drives, so to speak, just on a single PCI Express card slot. This is starting to get pretty smoking quick. And the bigger that your drive is, the faster it goes. This is kind of counterintuitive to what we wanted for a long time as DBAs. For a long time, DBAs were taught that you should have a whole lot of very small drives, not a whole bunch of, or very few, large drives. It's the opposite in the solid state world. Notice these are two Intel drives, PCI Express cards you plug into your server. The 400 gig drive is slower than the 800 gig drive. Why? Because the bigger your drive is, the more controllers and the more solid state chips it has. This is an example of one of those drives that actually has four separate controllers on board, plus dozens of drives, dozens of NAND chips stacked onto here that can all read and write data simultaneously. And then it gets even quicker when you start to pack in multiples of these into your server, because one of these really isn't a replacement for a SAN. You want to have pairs of these in your server because one of these drives can and will fail, just like hard drives fail. The vendors are always, hey, look, man, this will last nearly forever, and when it fails into read-only mode. SQL Server is not very good at handling drives that suddenly fail into read-only mode. So what you really want to do is RAID these together. That does mean you're going to be using Windows RAID, aka software RAID. That is not bad. It had a bad reputation back in the Win 2003 days, but trust me, software-based RAID is going to smoke the daylights out of that really crappy SAN that you've got that's really dogging you in terms of speed. Now notice also, we were talking about how much read throughput you need. We said that we need to get 200 megabytes per second of throughput per core. When you get a pair of these things, this is how you're able to keep lots of cores busy. And when I say lots of cores, even just a 2 Xeon 6-core system, you need a pair of these smoking fast solid-state drives just to keep those CPUs busy. This is why TempDB on solid state is so insanely great. For relatively cheap amounts of money, you can make the server's TempDB crazy quick without having to invest a whole lot in your SAN. Now, of course, these things can and may fail. This is why clustering is so fantastic, because you can fail over from one node of the cluster. But what I'm really trying to do here is free up that very tiny straw, that straw that we're drinking our data from across from the SAN, free up that straw so that I'm only using it to get user data, not TempDB data. Because if I have to performance tune that really tiny straw, that's going to be expensive. That's going to cost tens of thousands or hundreds of thousands of dollars, and TempDB on solid state is way cheaper than that. So our big takeaways out of tonight's session: first off, pathing matters so incredibly much. It matters so much about how quick we can get data from storage, how big that straw is that we're drinking data from. We are not the only people drinking data through that straw. These are social networks where lots of people are talking simultaneously. Lots of servers are talking through these same exact straws, which makes them even slower. A big reason why virtual SQL servers suffer so much from these virtual I/O problems. It's hard to even get this right on a physical server, let alone in a virtual environment where lots of virtual servers are sharing a couple of really tiny straws. You want to get your vendor SQL Server instructions, preferably the fast-track data warehouse reference architecture configurations, and then hold your SAN admin accountable. Test with Crystal Disk Mark and SQL.io, and don't install SQL Server until after you've proven that the SAN can actually go up into the red zone and really drive a lot of data through. And then finally, get all of this documentation that I've been talking about tonight from brentozar.com/go/SAN. So that's everything I wanted to talk through tonight. What questions do you guys have from tonight's material? Now's your chance to come up to the front. And I didn't look to see if you guys are muted or not. Yeah, no, you're not muted. Okay, so you can ask questions there.
Hi, you can hear me?
Yes, yes I can.
Hi, you said to put TempDB on SSDs. The SSD has degradation of, I don't know, 20,000 reads, writes, I can't remember exactly. But the performance degrades over time. Is that not going to influence it with all the reads and writes constantly with TempDB?
Yeah, that's a really interesting question, and it depends on the make and model of solid state. One of my favorite sites for this is tomshardware.com. I'm going to pull up a web browser, always dangerous to do during a demo. I'm going to pull up a web browser and go to tomshardware.com. Up at the top, if you go to charts and then hit solid state drives, there's always a list of the best solid state drives for the money, and this changes from month to month. Some solid state drives do not degrade over time. A great example of this is Intel solid state drives. Now, they're not as quick at the beginning. You know, they trade off that continuous load pattern instead of being fast and then slower later. The great example is StackOverflow.com. I do database administration for StackOverflow.com. We used the same Intel drives for 3 years straight. And during that whole span of 3 years, our writes never went over 1 millisecond through the entire life of the drives. We ended up replacing them just because we needed more space, not because we needed more performance. And that's not universally true for all Intel drives. You always want to go look at the reviews for the drives you're about to buy in order to find out which ones degrade over time and which ones stay constant.
Okay, thanks.
Any other questions? Over Twitter, and I don't think we had any questions over in Twitter. Nope. Shai Engelberg says he's on stage next to talk a deep dive into Hackathon. So with that, I will let you guys go, and I will let Shai Engelberg take over. I should look at what his real name is. Oh, it's not even on his profile.
Brent, you hear me?
Yes, yes.
It's Guy. I just wanted to say that we are around 70 people here in the Israeli user group.
Ah, cool. Well, I hope you guys...
Great presentation. Thank you very much. On behalf of everyone.
Thanks. Glad you guys liked it, and I'll see you next time.
Thank you, Brent. Thank you.
You bet.
See you. Bye.